So the Earth has something called the EM field. Here it's called the magnetosphere. Basically, it's electromagnetic field that protects the Earth from the solar winds. Solar particles, solar whatever, things flying off of the sun that wants to hit us. Okay, the EM field protects us from this. So what happens is the particles fly off of the sun, however it does that, which we'll get to in Chapter 9. Then the particles get trapped in what's called the Van Allen belts. And you can see those are kind of the lines that go around the Earth here. And then in the blown up picture, the particles actually twirl around these Van Allen belts until they hit the north and south poles. And where they interact with the atmosphere is how we get the northern light. So as the particles are swirling around the Van Allen belts, they finally get down to the poles, right? And where they interact with the atmosphere, this is where they can kind of escape and hit the Earth, but they don't really affect us. What happens by this point is when it hits the Earth, you get the northern and the southern lights depending on which part of the Van Allen belts they were guided.
What's the timeline here?
As the EM field becomes more and more unstable, we'll start seeing isolated incidents. One plane will fall from the sky, and then two, and then in a few months, everything electronic will be fried.
Static discharges in the atmosphere will create superstorms with hundreds of lightning strikes per square mile.
After that, it gets bad.
The Earth's EM field shields us from the solar winds, which are a lethal blend of radioactive particles and microwaves. When that shield collapses, microwave radiation will literally cook our planet.
Dr. Zimsky, this is the sun. This is the Earth without the EM field. Would you?
Three months, gentlemen, and we're back in the Stone Age. A full year, the field collapses, and that.
Yeah. Feel free to throw up. I know I did.
So, how do we fix it?
We can't.
Not in my vocabulary.
Then you might want to get one of those word-a-day calendars, General, because it's impossible. The core is the size of Mars. You're talking about jump-starting a planet. This is a superheated hyperfluid of molten iron and nickel at 9,000 degrees Fahrenheit, 2,000 miles down, 1,000 miles thick. And the deepest we've ever been is 7 miles with a 2-inch drill bit.
If we can go into space, we certainly...
Well, space is easy. It's empty. We're talking about millions of pounds of pressure per square inch. Even if we somehow came up with a brilliant plan to fix the core, we just can't get there.
Yes, but... what if we...
So that clip was from one of my favorite movies, The Core, and it talks about what would happen if the EM field stopped, right? So with that in mind, here's the moon's EM field. Again, you don't want to live on the moon, but it'd be a lot easier to study than the Earth.